if you have my hand, which point will have more angular velocity? This or this? Angular velocity, not linear, angular. Angular velocity is the changing angle over the time. It's the same changing angle over the time from here to here than this one. Tell me the angle. How much is the angle changing this from here to here? 90 degrees. How much is the angle change for this point when I am changing from here to here? 90. So delta theta is the same? Is the same. So over the time, the velocity, angular velocity, will be the same for this point than for this point. For this point, for this point, for this point, for this point will be the same angular velocity, but the linear velocity will be the same. Which point will have a greater linear velocity? Which point will cover more distance over the same time? The outer point. This you can see in this formula. So if R change, V will change, but omega doesn't matter if it changes or not. All points will have the same angular velocity. This is the next. What will happen if V change over the time? Delta V over delta T. What will change over the time as well? This or this? Omega. So we get delta omega over delta T time R. What will be delta omega over delta T? Alpha. So we get that the tangential acceleration is equal to what? Alpha R. These three equations are very important. Why? Because they connect the linear motion to the rotational motion. So in addition to what we learned here, we have to add these three equations. S theta R, V omega R, and AT alpha R. In addition to that, we can have radial acceleration or centripetal. What will be the radial acceleration? V squared over R. And if we substitute instead of V, omega R, what do we get for centripetal acceleration in terms of this value? Radial acceleration will be omega squared, R squared over R. What we will get? Omega squared, R squared over R. That's the centripetal acceleration. What we have in the board is kinematics or rotational motion. What will be the typical question? Very simple. Given theta as a function of time, typical question. I finished with the theory. This is the theory of kinematics. Of course, the theory of kinematics is much smaller than the theory of dynamics, which is the Newton laws and everything. Here, if I give theta 3t squared plus 2t plus 1, this is the way that theta changes with the time in radian. What can I ask? I give this as a function of time. What do you think that I will ask? Find the angular acceleration. What else? Find the velocity, angular, right? What else? I can, if I give the radius, I can ask for the linear velocity. So I can ask for the omega, I can ask for alpha. Let's say I want to find what will be omega at any time, which means the function of the velocity, angular, omega at any time. What can I do? What can I do? I find the derivative. Omega will be d theta over dt. Get that? So I want omega at any time. What will be? 6t plus 2. That is omega. 6t plus 2. If I said, okay, find omega at 2 seconds, what do you do? You just plug it in at 2. So we get 6t plus 2. I ask, find omega at 2 seconds. You plug it in, and you find what will be in radian per second. Get the acceleration, angular. Get alpha or angular acceleration. What do? You derive again, find the derivative again, and then you plug it in. If I said find alpha at 2 seconds, what will be? 6, which is constant. Right? Same thing that we did before. Now, with the new terminology, but will be the same. Let's say that I ask, find the average find the average velocity between 2 and 6 seconds. What do? Average angular velocity between 2 and 6 seconds. What do? You plug it in 6 and you get the angle at 6 seconds. Theta at 2, you get the angle at 2 seconds. You find delta theta over delta t. Same thing that we did before. Can you see that it's the same that we did before? Now, I give that the radius, this is a wheel that is rotating under that equation, right? But I said that the radius of the wheel is 2 meters. Find the linear velocity at 2 seconds. What do? You just find omega at 2 seconds, and you multiply by what? By the radius. You get the linear velocity at that moment. The same will be, find the tangential acceleration at 2 seconds. What do? You find alpha. Once we have alpha, we multiply by the radius. We get the linear or tangential acceleration. Any question? That's the theory behind kinematics or rotational motion. The typical question will be that. So the same thing that we did before. Now, if I give B initial, omega initial, and the time, and omega final, and I ask for alpha, which big three you use if you know that it's moving at constant acceleration angular? What do? I want alpha. What do? You use the first. I give that the object revolves 2 revolutions. 2 revolutions. Starting from rest. The acceleration angular is at a constant rate of 2 revolutions per second square. 2 radian per second square. 2 radian per second square, alpha. And I ask, find what will be the time. The time to reach the 2 revolutions. How long does it take to reach the 2 revolutions? What do you use? The second. But I gave the acceleration alpha, angular, 2 radian per second square, and I gave that delta theta is 2 revolutions. What do you have to do? You convert which one? The revolution into what? Into radian. How do? You multiply by what? By 2 pi. Any question on that? This is kinematics or rotational motion. Of course, I will give a study guide, and we will go over certain problems. Here is just the theory. Because I didn't bring the study guide today, I want to cover as much as I can of the theory, just to use 1 or 2 days to just do problems. Okay, so kinematics of rotational motion is basically very simple. It's just what you learn, use the new letters. Understand what is the meaning of the new letters. And what is the connection between the 3. 3 important equations. Boom, here. I will say 4. That's it. Knowing that, we move to dynamics of rotational motion.